Hello and welcome everyone to the final code walkthrough. It's been a long series over many months, covering just about everything in the drand code base and in how to use drand effectively. The final session is going to be on the drand clients and how to use them. In retrospect, it probably should have been one of the first sessions, because for people who don't want to contribute to drand itself and just want to use it, using the clients is the most important thing. You might ask, why use a drand client at all? Obviously, we provide API endpoints. You can curl the latest round of randomness, and ta-da, you have got randomness. But the important thing about the clients is that out of the box they provide verification for you, so you don't need to pull in your favorite BLS12 381 library to verify the randomness beacon once you've got it. And of course, I cannot possibly suggest anyone should use drand randomness without verifying the beacon itself. Who knows, at some indeterminate point in the future, the drand network or the Protocol Labs drand infrastructure might get hacked and start providing invalid beacons, as unlikely as that may be. So, for the safety of your users and yourself, obviously you should always verify the drand randomness. So the easiest way to do that, at least in any of the languages where it's easily supported, is to use the drand client. So we've in fact got three widely supported drand clients, or official drand clients, you might want to say. The first one is the Go client, which lives in the drand repo itself at the moment. For drand v2, we are planning to pull this out of the core drand repo and move it into a separate client repo to allow us to add new transports, new schemes, and I guess evolve the drand client separately to the drand core database. Also, because it's a little bit hard to find in here, it's kind of, obviously it's a directory labeled client, but if you want to import it in Go, you've got to get the right path and pull in all the right stuff, and it's a little bit more fiddly than just having a separate GitHub repo for the Go client. The second client we have is a JavaScript client called drand-client. In retrospect, we probably should have called it drand client JS, but unfortunately, hindsight's 2020, and it's now the drand-client. It's written in TypeScript, but as such, it is usable in JavaScript, and in fact, I think also usable in Deno, as we provide the compiled and minified JavaScript in the repo out of the box. I think it's minified. I probably should check that. The final supported client is drand client RS. Obviously, we learned from our hindsight mistakes of the past and added a suffix on this one because it couldn't also be drand-client. It's a Rust native client. There are actually multiple community offerings for the Rust side of things, so you might possibly use the drand verify crate from Cosmos, or the Noise team who are building on Cosmos. You might also use drand RS, I think is a repo name from Thibaut Meunier from Cloudflare. It supports some extra goodies like time lock encryption. I think the Noise one supports WASM and multiple backends actually for the cryptography. So in the Rust world, if you're running a native machine, you might want to use Blasters as your BLS backend because it does some stuff in assembly that makes it super fast. But if you're on a blockchain, you might want to use WASM. And if you're in a browser, you might want to use WASM, etc., etc. So those are all other options. Today, we're just going to present our official drand client RS because it's what we know best. Okay, so those are the repos here. Small point to note that the Rust client is in the randa-mu GitHub namespace rather than the drand one like the other two. But it's also available on crates.io and all the usual good stuff. Same for the JavaScript client, it's available on npm.js and Good Guy Go. You can just pull it straight from GitHub and should all work. So let's, to that end, look at the Go client first. So I've got it conveniently open here. It was the, let me make it slightly bigger because I've got a massive screen. Oh my goodness. What the? Okay, that didn't seem to work particularly well. Okay, wonderful, wonderful. Okay, so this was the first of the clients to be built, and to that end, I think there are some warts. It's slightly less easy to use than some of the other clients. It was developed with drand in Filecoin in mind, and as a result, a few of the design decisions are such that it's optimized for use in Lotus. In particular, when creating a client, you have to wrap multiple clients that can have multiple different transports, which is very flexible, but for the average user who has not used drand before and just wants to get a beacon, it's a little bit spicier. But we'll start off in the interface here. So here we have a client interface that provides a bunch of useful stuff here. You can get randomness by a specific round. You can also watch and get a channel back for every new random value that gets emitted by the network. Additionally, you can get the chain info here. Essentially, that is the details that are generated once a network has been founded and in fact updated whenever a resharing has happened. That contains stuff like the public key for the group, the genesis time for the network, the period, i.e. how often it emits a random number, transition time, which is the last time it was reshared, a whole bunch of other stuff. I probably could have just opened the struct to show you that, but here we go. Oops. Also the scheme, very important, very important. Also we have this round at function, which really is just a, could probably be in a pure function, but anyway, essentially for a given time it tells you what the current round is at that time, rounding down as it were. So if you're slightly later than a round being emitted, you'll get that round's number and not the next one to come. And the IO closer interface here, that is, you know, pretty standard stuff to do some cleanup. Result here mirrors a beacon basically. So we've got a round, you've got some randomness, you've got the signature, where the randomness is SHA-256 signature digest over the signature. I suppose a small point to note, if you're in the Filecoin world, they actually use Blake 2 to derive the randomness from a signature. But drand network by default and the binaries run by the LOE provide the randomness as a SHA-256 digest over the signature. Again, you can use any derivation function you want in the real world, and you could in fact implement your own client to do that if you so desired. Okay, so we've seen the interface, we can see what it can do. Let's go to sort of the canonical implementation you might say, which is the HTTP client. Let's make it bigger. Oh, come on, yeah. So the key parts here are that you have to provide some URL and some chain hash. So that means you've got to have the chain hash out of band to ensure that the beacons you're getting from the network are valid. Essentially, if it's the wrong chain hash, then you might be connected to the wrong network. This helps verify some of the requests you make. URL in this case is of course the API you're getting it from. As drand randomness is verifiable no matter where it comes from, you don't necessarily have to get it at api.drand.sh. You don't necessarily have to get it from Cloudflare. In fact, you don't have to necessarily get it from anybody who's participating in the network. You could get it from any CDN that hosts drand beacons, which there might not be any, apart from Protocol Labs, Cloudflare, StoreSwift, and I want to say somebody else. If I've forgotten them, I'm very sorry. But you could get them from anyone, basically, in principle. So the details of how we build a client here are not super exciting. Essentially, it fetches the chain info using the chain hash. As the chain info for every chain hash is available, / the chain hash. /info on the standard API at least. And add some user agent, does some magic. Essentially, you'll get back a client that conforms to this interface. You could use that just as is out of the box, but in Filecoin land, and maybe for other distributed systems or resilient systems, you may want to use this client wrap function. This wrap function, in essence, allows you to take multiple different clients and speed test each of them, and whenever you call, for instance, to get the latest randomness or call the watch function, it will use the fastest one to you, and if one of them goes down, they're constantly speed tested, which can be configured in the options, and that speed is kept up to date. Not only that, but it also allows you to use multiple transports. So in Filecoin, for example, randomness is published, well, in drand randomness is published on libp2p using gossip sub. So if you're running a storage provider in the Filecoin network, you could get your randomness from HTTP endpoint, or you could get it from gossip sub, and depending on where you are in the world, one or the other might be faster. And of course the availability of the endpoints that you use. So this, I think, one detriment of using the new client directly from this function is that out of the box it actually doesn't do verification, which is a little bit bizarre. But when we use the wrap function to create clients, we create this sort of Russian doll of different functionalities, which we can see in this make client function. What we do is, firstly, we create a cache for rounds using this client. This is maybe not that useful for people who are maybe making a web app or simple app against randomness, but in the context of a relay or a storage provider, this is quite useful, where you might get the request for the same round multiple times and you don't want to have to go and get it every time. Additionally, there's this watcher client, which as we saw in the interface, allows you to get the randomness as soon as it's available, rather than having to sequence it yourself to request the randomness. It wraps some of these clients in a verifying client, which in essence is the difference between just getting the random value and using it, and getting the random value, verifying the random value, and then using it. It then wraps this verifying client in an optimizing client, which, as I mentioned before, speed tests all the clients that you pass into it to ensure that you're using the fastest one at all times, which could be very important for some use cases, particularly where you need randomness every epoch. And also it adds some metrics here for Prometheus. Prometheus being the most popular, as far as I'm aware, most popular tool for aggregating metrics and using them for things like Grafana dashboards. So maybe to see an example of how this is used, we could see in, let's go to the optimizing test. In fact, no, let's go to the HTTP test. We can see, in fact, let's not use this one. I want to see the where we use the wrap functionality, because it's a slightly spicier one. Okay, client test, yeah, that would make a lot of sense, of course. So I think the tests are quite a good reference. I mean, in all the drand code bases, actually, the tests are quite a good reference on how things work and how you should use things. Of course, the drand daemon has a massive array of tests that do everything you could ever imagine, but for the clients, they're a little bit slimmer, a little bit clearer to see what's going on. So here is the wrap in flight. We create this array of different clients. Here we just got one, it's an empty client. And we can pass in the chain info rather than fetching it out of band and the chain hash as well. And wow, we don't actually use the randomness in this test. Let's see if we can get a get somewhere here. Okay, here we go. So we in fact set up an HTTP server. Also, for people just using HTTP clients, you can also simulate this wrap by using the 4 URLs. So in the case that you want to pass multiple HTTP endpoints but don't want to use like Gossip Sub or another transport, rather than using the wrap, you can just use the 4 URLs function, which does much the same thing as the wrap, but just for HTTP. And here we see we can request around. Wonderful, wonderful. Additionally, we can wait, it's kind of puzzling. I thought this was going to be the watch here, but we can also use the watch function, which ought to be somewhere in here. Oh, ooh, that is indeed quite awkward. I have been recording it, but I have not been sharing it. Okay. Wonderful, wonderful. That's quite unfortunate, but luckily it's being recorded, so hopefully you can watch that bit back later. Okay, so the watch, as we said, it returns a channel, gives you the latest randomness, so it should, you can use it to get each random value as it comes in from the network. Okay, that is more or less everything for the Go client. Hopefully, Korean, you don't use Go, and this was all totally useless to you anyway. But long story short, we've got, it supports multiple transports, libpdp, HTTP out of the box. A small point to note, actually, it also, there is a gRPC transport there, although as far as I'm aware, it's no longer used by any of the nodes, and they won't. Nobody exposes their gRPC endpoint to the world. So at least for contacting the drand network, as the LOE's drand network out of the box, gRPC transport's no use. But if perhaps you want to serve beacons yourself to your own network, you could use a gRPC for transport. It supports watch. You can get by round. You can also work out the latest beacon by using the round at call as seen in the interface. Okay, that's everything for the Go client. Are there any questions? Wonderful, wonderful. Okay, with that in mind, let us then move on to the JavaScript client. Here's one I prepared earlier. Except that it's quite small. So I'm going to start with the integration test for this one because I think it makes everything a little bit clearer. But in essence, in the JavaScript client, the calling to get randomness functions are just standalone functions. They don't live in an object. Instead, we configure the client by creating some other object and passing it in to those functions. So our core 3 functions, in fact, are the fetch beacon function, the fetch beacon by time, and the watch function, similar to the Go client. Fetch beacon, of course, you can pass a round number. Optionally, if you don't pass a round number, you'll get the latest beacon. Fetch beacon by time, no surprise there. It gives you the latest beacon has been emitted at the time you pass in. And the watch returns this async generator, which is a little bit, not really like a channel, but kind of like a channel. And you can also cancel and do all kinds of cool stuff. If you're making, for instance, a game in a web browser, this watch could be super useful. In essence, obviously they function very similarly to the Go code, except we don't have this Russian doll of different types of clients, wrapping clients necessarily. But where they differ is that we pass this chain client into the function. So as we can see here from our interface here, chain client looks quite similar to the interface for the client in the Go world. But these are all implemented kind of out of the box. The important bit here is the chain options. We can disable beacon verification if we want to take the guardrails off and go crazy. We can also blow the cache if, for instance, we don't want to have HTTP caching because we think maybe a beacon's going to change, which it shouldn't. And we can pass these chain verification params, which is analogous to passing the chain hash in the Go client. We can also pass public key. One difference, I suppose, to the Go client is that we pass the public key here, but we've conceptualized as getting chain info as its own interface. So unlike a let's scroll back down. Unlike a chain client, we've also conceptualized a chain interface, which encapsulates this base URL, so the api.drand.sh, and it knows how to get to chain info using that. Because having to implement those yourself would be a pain, we provide some out-of-the-box implementations, which also do, for instance, some caching and stuff for you. So we've got an HTTP chain that takes a base URL and takes those chain options we saw before. Also takes some additional HTTP options, which are things like if you want to pass a custom user agent, if you want to pass some headers, for instance, like an API key, if you had a told API, or who knows what other magical HTTP options you might want to pass. And so as the HTTP chain, the HTTP caching chain does the same, but anytime the info endpoint is called, it just gets cached. The info ends up getting used quite often to verify the beacons, because we need to see the public key, we need to ensure, of course it doesn't change since after a network's founded, so you might want to have, for instance, just a concrete HTTP chain implementation of your own, which you can find in the test, so that it just passes a public key and doesn't call out to the network at all. Also very possible. So just to go backwards then to our chain client, we also provide an implementation of a chain client out of the box. We have a couple, in fact. So the HTTP chain client is, unsurprisingly, an implementation using HTTP. You pass it as chain, which it uses to get the chain info deep in the bowels of this JSON error function. And it just has these two different calls: get a round number and get the latest randomness. We saw those were used earlier on, and we'll come back to it. Additionally, apart from the HTTP chain client, we also, provide this fastest node client. It is implemented, in fact, with an HTTP chain client, but it does the speed testing that we saw in the Go client to ensure that if you have multiple providers, that you're always using the fastest or closest one. And again, you pass it a bunch of base URLs. This doesn't support multiple transports in this implementation. So for instance, if you wanted to race a libp2p client and an HTTP client, you may have to implement your own. It shouldn't be super difficult. Obviously the blueprint is here, and we aren't aware of anybody using gossip sub for drand beacons in JavaScript, but if you are, reach out, we'd love to know. So yeah, you got to start it, stop it. It also I believe supports it doesn't. I thought it supported an abort controller, but it doesn't. I guess the watch function does though, so that's fine. Okay, let us go back to here. So we've seen all these functions now: fetch beacon by time, and watch. Like I said before, best place to understand how to use these is in the integration test. Some of this stuff is in fact copied in the README, so don't worry, you can read the README if you don't want to dive into the tests. Here's an example of fetch the beacon by time, pass some time in, we create a client here. Also on that note, in the index file we should have a bunch of, no we don't, okay, maybe that's just in the Rust client. Go. In hindsight, the keyword for the day, we should have provided a bunch of out-of-the-box clients for drand mainnet and drand testnet. Here I've created my own using the testnet URL. And we'll see in the Rust client that it provides a bunch of different ones for you to use. The time lock encryption library does, but this doesn't. Boo. That's potentially a job for me to do. But yeah, so you create this caching chain, very simple. You just pass a URL. You pass that caching chain into the HTTP chain client, very simple. And then you're off to the races. If you use the watch client. Alright, we use the speed testing client rather. So here, fetch beacon by time, very simple. Fetch beacon, very simple. And watch, very simple. This client was updated probably about 6 months ago now, my goodness, from a previous old interface. So this is now the V2 client for drand, for the JavaScript client. If you are stuck using the old interface, it is actually supported by this by the interface provided somewhere. Here, yes. This chain client interface conforms to the old drand v1 client, so at least as long as drand client v2 is around, you can still use drand client v2 in this manner if you want to not have to change your code too much. But if drand client v3 comes out at some point in the future, it might go away, so just a point to note. Okay, wonderful. That is everything from the JavaScript client. Are there any questions on the JavaScript client? There are not. Wonderful, wonderful. We'll now move, I keep moving this, to the Rust client. This is the latest and greatest, you might say. In keeping with latest and greatest, I'm using Rust Rover, JetBrains' new IDE for Rust. It looks a bit like VS Code, so I'm not sure how much I enjoy that. But alas, we've got to try these new things. So hopefully we learned all the lessons from the previous two clients to build one client to rule them all once the world rewrites everything in Rust. And yet again, we'll go straight to the tests because I think it's the easiest way to see how to use it. But again, it's in the README if you want to get the whistle-stop tour. In essence, we have a function, new HTTP client, that takes a URL, and then everything else is seamless and handled for you. Oh God, isn't that good? You've got the latest randomness. You can also pass the round number. Hold on, let me make this bigger. You can pass a round number to get a specific round. It returns a result, so there are a couple of error cases you can handle, which is slightly nicer because Rust is lovely and we all love it. Here, all these tests are for HTTP client, but in fact, you can provide your own transport. We've got a trait for the transport. It takes a URL. You might consider that string to be a URL or something that's a bit like a URL, depending on what wild custom transport you use, maybe file path, for example, or SID, or something else if you're using some strange and starting transport. The chain info here is fetched whenever you create the HTTP client. That's why this returns a result. But again, you can pass a trait of your own. Everything is generic over this transport trait. But in essence, that's kind of all there is to it here. Very similar to the old ones. Latest randomness, by round number. I guess one thing it's missing in this implementation, there is no watch function for doing the randomness. Rust, I was going to say Rust doesn't provide asynchrony out of the box. That's actually not true. There is an async standard library in Rust, although it seems like the world prefer to use Tokyo, which is another library for doing asynchronous computations in Rust. To not answer that question at all, we just don't put either of those in, and there's no watch implementation. But you could I'm sure it could be easy to implement on top of this. Like all the other libraries, this supports all the schemes. Probably should notice before, some of the other clients some of the community clients might not be up to date with all the latest and greatest. So I think at least the noise network and D from Thibaut are actually up to date. But these support all the schemes, so the default Peterson BLS chained, the BLS unchained, the unchained on G1, unchained on G1, RFC 9380. They're all supported by all the clients now. Yeah, as of quite recently. I'm not going to dig into the specifics of how that works, but there are some. If you like digging into some spicy cryptographic code, it's in here somewhere. Unfortunately, BLS libraries out there just assume that everyone's put in the signatures on G2, which, for reasons of space, we decided to not do, because we emit way more signatures than public keys. So our new networks create public keys on G2 and signatures on G1. If that made no sense because you hate the thought of maths, don't worry. But you can also read on the DRand website what that means. But I'm not going to go into it now. So that is. But before I finish up, I suppose, let's say, for example, you didn't want to use a client. Maybe you've already got your beacons from somewhere else. Maybe you don't want to write your own custom transport. Of course, you can verify a beacon yourself. So we've made this a public function so that you can pass a scheme ID, you can pass a public key and a beacon that you've got from somewhere, and you can verify yourself. This is also true, I think, of all the other, certainly of the JavaScript client. The drand client doesn't, in the Go code base, doesn't contain it per se, but the wider code base does, so you can pull in the verify yourself and verify beacon, but it's not embedded in the client. But it is in Rust and JavaScript, so fear not. No matter where you got a beacon from, you can deal with it. That is basically all I have to say on using the clients. Right now we aren't planning to target any more languages for clients necessarily, although if anybody in the community is dying for another client in some other language, obviously let us know in Slack. Python has been one that did get requests at some point. In fact, there is a drand Python client somewhere on the internet, although it doesn't support anything apart from the default scheme. So any hackers out there that like writing Python, feel free to develop one yourself, or if there's loads of interest, maybe we will, but there's been no interest so far, so alas, or little interest. Yes, with that, I leave you once more with the relevant repositories, and I'll take any questions if there are any further questions about using the drand clients. Wonderful, wonderful. Well, sure thing. We've got Go, Rust, and TypeScript. We've no plans for future clients. Although if there's a dire need for one, or a potential customer or user really wants one and can't develop one themselves, we could be open to it. It's fairly lightweight to write a client. I mean, it doesn't. It's not a crazy job. The most difficult part is finding the cryptographic primitives. So, for example, at one point I was going to write a Kotlin and thus JVM, Java, that whole ecosystem client, but actually there's no BLS 12.381 implementation in the whole JVM ecosystem, which frankly shocked me, which means that we can't verify the beacons, or rather we would have to write our own implementation, and that was going to be a side project, but it got thrown into the Sarlacc pit of side projects there that have not yet ever been finished, so maybe one day. Well, with that, I will end the final code walkthrough here. Hopefully, people love it, and we can get more code walkthroughs in future or some other form of presentation to make the community love drand even more.